Now, all right, this next slide, the potassium and the sodium channels. Now, ungated merely is the same as saying continuous. Because it's continuous based on concentration. Ungated means that it's not cycling based on the action potential. Ungated means if the potassium concentration goes up inside the cell, potassium will leave. If you have a cell, and here's the sodium-potassium ATPase, and the sodium-potassium ATPase is pumping potassium into the cell. Well, if you have an ungated channel, if the potassium concentration is going up inside the cell, what will happen is that potassium will leave in this ungated channel based on concentration. So when you see the words ungated, you should be thinking of two things: continuous and based on concentration. Continuous and based on concentration. Continuous, based on concentration. Last point, not affected by action potential. Yeah, because action potential is an electrical phenomena. Action potential is largely an electrical phenomena, changes the opposites. Remember what I said? Life is based. The entire joy and conductance of life is based on the struggle between opposites. Wow. And they don't exactly unite, but they do pass each other and get along pretty well. But ungated is not based on dipoles, on polarization, negative in, positive out, negative in, positive out, and then all of a sudden it switches. Ungated is not based on charge, it's based on concentration. Since it's not based on charge, saying not based on charge is the same thing as saying not altered by action potential. Not based on charges means not altered by action potential, because action potential is predominantly a concentration event or an electrical event. Is it concentration or is it electrical? And the answer is it is electrical. It's predominantly electrical. It may be created by concentration, but it's a change of electrical currents. So ungated is not affected by current, which is to say not affected by action potential, which is to say continuous based on concentration gradient. That's what ungated means. Now, voltage gated means is affected by action potential. As a matter of fact, it creates the action potential. Voltage gated means that it changes not so much on concentration, but based on charge. As a matter of fact, the voltage gated channels create the concentration differences in a lot of ways. So, voltage gated, not continuous. Voltage gated, affected by action potential. Voltage gated means it's created and affected, creates, affects, and is the entire cause of action potential and change in electrical dipoles. Cool. Remember that the natural continuous efflux of the cell is potassium out. Potassium out. Now, many students, because you're thinking of the sodium-potassium ATPase, many students will think that the natural state of the cell is the sodium-potassium ATPase, where sodium is being pumped out and potassiums are being pumped in. And that thing which potassium's being pumped in and sodium's being pumped out, that ATP step, is on virtually every live cell in the body. However, that is a pump. In terms of action potentials, you must remember that the action potential is passive. Now, this is hard for people because, passive, I mean, you mean an electrical shock going through my body, an electrical charge going from my brachial plexus to my fingertip is passive? It doesn't feel passive, it's an electrical shock, charge. I know, right? Remember that for physiology and for step 1, passive means it doesn't use ATP. Passive means it's the car running down the hill, not using gas. Passive means it's happening by itself. Passive means I give you your paycheck and you cash the paycheck. There's the energy, it just runs down by itself. Active means you made the work to make the money, but passive means you got the big paycheck, you go to the bank, it comes out of your cash machine, and you spend it and go out and do everything you do with your money. It doesn't mean that something's not happening, it means it's just not using action, it's not using energy. Passive means it's just not using energy. It's not consuming energy. You get paid, you put the check in the bank, you take the money out. Well, you already did the work. So in one sense, cashing the check and taking the money out and going out and taking your friends out to dinner, in one sense is passive because it's money that's created already. So just remember that electrical transmission, even though it could be a shock going down, is not energy producing. And that's a good thing too because it means it's faster. It's faster. We don't want slow stuff like that. Remember, people who had slow action potentials are not our ancestors. If you had an ancestor that had a skeletal muscle action potential of 400 milliseconds, well, he's not your ancestor. He's, brunch for a velociraptor. So, changes in conductance. Now, conductance means the transmission of ions. Now, I'm going to say the word ion, potassium, sodium, and I'm going to say that interchangeably with the term electrolyte, and ions moving in and out of cells is called conductance. Now you notice that we're interested in only a few of these, predominantly sodium and potassium. Calcium chloride lesser, magnesium not so much. Now in terms of this is what we're talking about. Neuromuscular transmission is created by the movement of sodium, potassium, calcium chloride, and conductance just means that they're moving in and out of the cells. Now, I want to be clear about this also. The major conductance of potassium, is it in the cell, into the cell, or is it going out? What's the major conductance of potassium? Is it going into the cell, or is it coming out of the cell? Is it going in, or is it coming out? The major conductance of potassium is it goes out of the cell. The efflux of the soul is happiness. To cheer, O Father, your boundless expectant souls. Who has gone far? For I would go farther. All right? Same with potassium conductance. Go farther. Out of the cell. Now, back to this slide. Depolarization. That means that the interior of the cell, is it normally negative or positively charged? It's normally negatively charged. Depolarization, does it mean that the cell becomes more negative, or does the cell become more positive? It means that the cell becomes more becomes more positive. Depolarization means that the normally negative interior becomes positive. Okay. Now, if the interior of the cell is normally negative, sodium going inside, sodium has a positive charge. Sodium going inside will make the cell positive. So in conductance, the main thing is that potassium's normal direction of conductance, is it in or out? Potassium is normally conducted out. Is it voltage gated? Is it passive and ungated? Normally, well, there's actually both, but the one that's continuous is ungated. When that sodium comes into the cell, the negative interior becomes more positive. That makes it depolarize. Now, repolarization means that those channels where the sodium is going in, you ready? The interior of the cell is normally negative. Sodium goes in. Sodium is a cation, and a cation goes in. That makes the interior of the cell positive. Depolarization, it becomes positive. Sodium rushes in fast. When the sodium channels stop, it will repolarize. Okay. Normally, it's negative in, positive out. When it starts to reverse, that is depolarization. When it goes back to its original, it's repolarization. What are the poles? Negative inside, positive outside. What do we call a neural tissue that's at steady state, where it's equal inside and equal outside and everything's the same? What do we call a neural tissue that's at steady state? Dead. That's called being dead. Okay? A lot of trouble, this thing. Tension between opposites. A lot of trouble. Nikos Kazantzakis in Zorba the Greek. Hey boss, life is trouble. Only death is no trouble. Life is trouble. Only death is no trouble. Now, the sodium channels. This thing is going to be said about 5 times. Okay? When the sodium channels open, the sodium goes in. The sodium is positively charged. It makes the interior positively charged. Repolarization. Those fast channels close. And the charge starts to come down. Starts to become negative. Now, how come we go too far? How come it hyperpolarizes? Hyperpolarization. Does it mean the inside of the cell becomes more negative or more positive? Hyperpolarization means that the interior of the cell becomes, well, the normal is to be negative. So if you're hyper-normal, like Dr. Fischer, what am I? I'm a continuous state of hyperpolarization. I'm just the same as all other men, just more so. And remember, all great men are dead, and I'm not feeling so well. So at the end, you hyperpolarize by the potassium channels opening. Remember, potassium channels opening. Does the potassium go in or out? The potassium will go out of the cell. We're going to do this visually in a second. And then what happens is that the sodium-potassium ATPase will clean it up at the end, because the sodium-potassium ATPase will take potassium into the cell. Now let's do this where we can actually see it in the picture, okay? Look, ready? If you get this on the 4th time, you're doing great. If you got it on the 1st time, you're lying. If you got it on the 3rd time, you're in good shape, okay? It's not so easy, this stuff, okay? It's not so easy. And then, because you might have just been able to understand this here now, and now let's put it in the form of this chart. Ugh. Now, the first thing is to remember that if we have the cell here, and the cell is normally negative inside at -70. The first part of depolarization. It's normally positive outside and negative inside. Depolarization, changing the poles. What do the poles mean? It's like a battery, baby. It's a battery. What's a battery? It's just like a battery, right? Here's a battery, right? The top end that's there, that's the positive end of the battery. And the negative end of there, it's just like a battery. It's a battery that gets flipped upside down. So the first step in making the inside of the cell positive, what goes in? Sodium. Sodium goes in. Sodium is positively charged. The sodium goes in, and what happens to the voltage? The voltage becomes positive. Ooh, the voltage becomes positive. You see, +70. The voltage becomes positive. The voltage becomes positive on the interior of the cell. That's depolarization. Now, G. G means what? G means conductance. G means how fast that ion is moving. All right. Actually, you ready? It's not any harder than this. The interior of the cell is negative. You get a fast conductance of positive stuff inside, so it becomes positive. Yeah. Like it used to be negative. And now this positive stuff comes in, and now it's positive. Yeah. All right. Yeah. It's like taking an antidepressant. It used to be very negative. Hey, you got an antidepressant. Now you became positive. Okay. Now that's depolarization. Now, when these channels, the sodium channels, get blocked, depolarization polarization is based on this positive ion going into the cell. When it stops, yeah, it starts out as very negative inside. And then like the positive thing goes in. So if the positive thing goes in, the thing inside must become positive, yeah. Used to be polarized. Now it's unpolarized. But we don't like to say unpolarized or mess up polarized, screw up polarized, not polarized like so much anymore, or like she used to be polarized, now she's not. So I will say you're depolarized. Okay, depolarized, fine. Tired of waxing, tired of threading. Let's depolarize your hair. Okay, could call it that. Hair depolarization. Why didn't I think of that? Why didn't I think of that? You can see a whole chain of Conrad Fischer hair depolarization shops. So, the sodium goes in, the sodium's positive, it makes the inside look positive, and then you know what? Like the sodium stops going in. And if the sodium going in made it positive, but then like it stops. So sodium going in made it positive, and now it stops, so it ain't so positive. Oh, the positive thing stopped, it ain't so positive. Okay. Now the other thing is conductance of potassium. Ready? Conductance of sodium goes in. Conductance of potassium goes out. Conductance of potassium is going the opposite direction. So since the conduction of potassium is going the opposite direction, that means potassium leaving. The positive thing leaving makes the interior of the cell negative. And that's why the voltage comes back negative. The positive thing, sodium, this positive thing of sodium stopped going in, and another positive thing, potassium, started leaving. The positive people stopped going in, and the positive people that were there started leaving. Everybody inside is depressed. Now, you see that this conductance of potassium is later? Since that conductance of potassium is later, that's what results in the hyperpolarization. Goes too far. Goes too far, hyperpolarization.